In this lesson, we will examine 4 more exponent laws. The first law is the power of a product law. Now, to set up this law, please consider the following example. One way to simplify this expression is to rewrite it as the following product and then rearrange the terms like this. Now, to find the product of these 3 terms, we can apply the product law, which says we must add the exponents to get x to the power of 30. Similarly, we can apply the product law here to get y to the power of 21. So x to the power of 10 times y to the power of 7, all to the power of 3, is equal to x to the power of 30 times y to the power of 21. Now notice that if we take this exponent 3 and multiply it by this exponent 10, we get this exponent 30. Similarly, if we multiply 3 by 7, we get 21. We can generalize these results as follows. So if we are raising a product to a certain power, let's say n, then to simplify this, we multiply n by the exponents within the product. For example, to simplify this, we take the 5 here and multiply it by the exponent 4 to get w to the power of 20. Then we multiply 5 by 2 to get x to the power of 10. And finally, we multiply 5 by 3 to get y to the power of 15. Now, to simplify this expression, we must first recognize that since 3 here has no given exponent, it is assumed to be 1. Now, when we apply the power of a product law here, we get the following. From here, if we wish, we can evaluate 3 to the power of 4 to get 81 times x to the power of 28 times y to the power of 40. Now, the next law is similar to the last one. To set up the power of a quotient law, please consider the following example. Now, one way to simplify this is to first rewrite it as follows. Now, when we multiply all of the numerators, we get x to the power of 15, and when we multiply all of the denominators, we get y to the power of 50. Notice that when we take the outside exponent here, 5, and multiply it by the 2 inside exponents, we get these new exponents. So we can generalize these results as follows. If we are raising a quotient to a certain power, let's say n, then to simplify this, we multiply n by the exponents within the quotient. For example, to simplify this power of a quotient, we first multiply the outer exponent, 11, by the exponent in the numerator, 7, to get k to the power of 77. And then we multiply 11 by the exponent in the denominator to get w to the power of 33. Now, to simplify this power of a quotient, we first rewrite x as x to the power of 1. Then we multiply the outer exponent 3 by the exponent in the numerator to get x to the power of 3, and then we multiply 3 by the exponent in the denominator to get y to the power of 18. Now, the next 2 laws are extensions of the first 2 laws. To introduce the first combining bases law, please consider the following example. To simplify this, we can apply the power of a product law to get x cubed times y cubed. Notice that this equation tells us 2 things. It tells us that we can take x times y all to the power of 3 and rewrite it as x to the power of 3 times y to the power of 3. It also tells us that we can take x cubed times y cubed and rewrite it as x times y all to the power of 3. Now, to generalize these results, we can say that if we have a product where the 2 exponents are equal, then we can rewrite this as the product of the 2 bases, all to the power of that exponent. Now, please note that in order to apply this law, the exponents must be equal. So, for example, since 2 and 7 are both raised to the power of 3, we can rewrite this as 2 times 7 all to the power of 3, which is the same as 14 to the power of 3. Similarly, we can rewrite this as 9 times 11 all to the power of 10, which is equal to 99 to the power of 10. Finally, the law even works here since 2, 5, and 6 are each raised to the power of 8. We can rewrite this as 2 times 5 times 6 all to the power of 8, which is equal to 60 to the power of 8. Now, the next law is so similar to the previous law that we will use the same name. This law involves division, but the principle is pretty much the same as the last law. To simplify this expression, we can apply the power of a quotient law to get x to the power of 5 divided by y to the power of 5. This means that we can take x to the power of 5 divided by y to the power of 5 and rewrite it as x divided by y all to the power of 5. To generalize these results, we can say that if we have a quotient where the two exponents are equal, then we can rewrite this as the quotient of the two bases all to the power of that exponent. Once again, please note that the exponents must first be equal before we can combine the bases. So, for example, we can rewrite this as 40 over 8 all to the power of 7, which is equal to 5 to the power of 7. Similarly, we can rewrite this as 18 divided by 2 all to the power of 16, which is equal to 9 to the power of 16. Okay, let's summarize. In this lesson, we learned more rules regarding exponents.